the vertical one. Okay. Now sometimes, like we're going to tomorrow talk about word situations, something is on the y-axis. If it's on the y-axis, what's its x-coordinate going to be? 0. And so what we say is another name for the y-intercept is the starting value, because it's where the graph starts, or the initial value. Okay. So, again, these are things that I think are review, but that we should make sure we know them before we get into slope-intercept form. So, slope-intercept form, like we said yesterday, looks like this. Y equals mx plus b. And yesterday, I focused mostly on the slope. Do you remember which one I said was the slope? Good. And so this m represents don't tell me the x at all, just the number in front of x represents the slope. Okay, so then we didn't talk about this yesterday, but what is b? Yeah, so m is the slope, and then b is the y-intercept. Okay, so let's put a box around b. This is the y-intercept. Now, sometimes we don't see anything here. It's just y equals x plus something. Even though we don't see anything, if it was y equals x, what would be in front of x? A 1, yeah. So make sure you realize that. Okay, so last unit we talked about parent functions a little bit. They are the most basic functions. Remember how we talked about an x squared and it's u-shaped, right? Do you remember we talked about a v, absolute value? Okay. The most basic of a type of a function we call the parent. It's kind of like, hey, this is where all the other functions, the baby functions, come from. So a parent function is the most basic of a type of function. For example, probably the most basic quadratic, I would say the quadratic parent function was x squared. Does anybody know? I'm guessing you won't, but maybe. Does anybody know what is the most basic line? Well, all lines are straight. Does anybody know the most, if I said, what's the equation for the most basic line? Actually, more simple than that. The most basic line is the line y equals x. The line y equals x, do you notice that there's no b behind it? Couldn't I write plus 0? So guess what the y-intercept is? 0. And there's nothing in front of x, but really what number is there? 1. Okay, so the most basic line has a slope of 1 and a y-intercept of 0. The line y equals x means every x coordinate is its y coordinate. So it goes through 1, comma 1, 2, comma 2. 3, comma 3. Is that making sense? If the x coordinate is the y, if I said find another point, 5, comma 5. If you would graph that, what would happen is you'd start at 0 and you'd go up 1 over 1. Do you see how it goes through 1, 1? And I'd go up 1 over 1. That's 2, 2, and 3, 3. So the most basic line is y equals x, and that's what its graph looks like. Okay. Just to review some things from earlier on. Ooh, let's see. Independent. Do you remember? What's some other words for independent? Hey, good! Somebody said input.
I did.
Input. Independents are input. What variable is the input? The x. And there was these words we used to describe them. Look at you, Abby. Nice job. Domain. Good memory. Good memory. So then, let's flip it around. What would the dependence be? The output. The y value in the range, right? Okay. All right. So if you're thinking of what depends on what I put in for x, I can put in anything I want, but the y depends on what I put in for x. So that's why it's the dependent. Okay. So let's use what we know about slope and the y-intercept, and let's graph a line. So first of all, this is my equation. Y equals negative 2/3 x plus 1. So would you guys tell me what is the slope of that line? Negative 2/3. Okay. And then what is the rise then?
X plus 1.
No, if the slope is rise over run, let's break it down. What's the rise?
Oh, yeah.
I'm going to say down 2. And what's the run? 3. Okay, so in a minute, I'm going to be going down 2 to the right 3. Down 2. Cody, what was that? The y-intercept is 1. Okay, and so Diamond earlier said the y-intercept is where the line crosses the y-axis. So I am going to start by putting the y-intercept on there. The line crosses the y-axis at 1. That is this point right here. 0, 1. It's where it crosses the y-axis. From that point, I am now going to do rise over run. So what am I going to do? I'm going to go down 2 over to the right 3. And I'm going to put another point. It looks like it's at the point 3, negative 1. Do you see that? Okay, so you, again, from this new point, you can again go down 2 over 3. It goes off the page a little bit. Would you use a straight edge? A straight edge doesn't have to be a ruler. It just has to be a straight edge. To neatly then draw a line through those points. Okay, and then I'm going to label, this is my y-intercept right here, of 0, 1. All right, so let's then do one more example, and I'm gonna use it in a word situation, but this doesn't have to be a word situation. This would work as long as you know 2 points. So in the title of the graph, it is the length of a spring attached to a weight, but do you see how I give you 2 ordered pairs there? Okay. And so now you might be able to kind of tell, but the issue with this is I don't think I have the y-intercept. But I'm going to backtrack and figure it out, okay? So, can anybody tell me how I'm going to do the slope then? I have a little box here for it. If I have the point 212 and 518, how can I figure out the slope? What do you think, Riley? y2 minus y1? Alright, so what would I subtract on top? But this is an x and a y. I want to have y2 minus y1 or y1 minus y2. Okay, but those are x's. Okay, so on the top is going to be, you can do 12 minus 18. Okay, if I do 12 could you do 18 minus 12? Yes, that's fine, as long as you keep it consistent on top and bottom. But if I did 12 minus 18, what must I do on the bottom? 2 minus 5. Okay, what is 12 minus 18? Negative 6. And what's 2 minus 5? Negative 3. Can't I simplify what's negative 6 divided by negative 3? Divided. 2. Okay. Oh, that makes sense. So doesn't this line go up 2 over 1 then? Now, the problem is it's not going up 2 tick marks because it's a tick mark 1. That's 5. Okay, but let's backtrack. Let's figure out what the y-intercept is, okay? If I went back to 1, can you guys figure out from the slope, remember I went up 2 over 1, what was this point? 1 what? Thank you, 110. Because to go up 2 over 1, wouldn't I have to go up 2 from 10? Isn't that 12 over 1? Okay, good. Let's go back one more step. This would be the point 0 what then? 0, 8. Because if I wanted to go up 2 over 1, 8 up to 10 is up 2, right? Okay, now I have what I need. Because what is the slope? 2. What is the y-intercept? 8. Alright, what is our equation in slope-intercept form then? Riley?
Y equals 2x plus 8.
Very nice. Y equals 2x plus 8. Y equals mx plus b. M is the slope, b is the y-intercept. Okay. Now, we're going to spend a lot more time with this tomorrow, but I said interpret the slope. Well, slope is rise over run, right? But what is the rise in here? The length of the spring, right? And what's the run? The weight. So here's how this, it's basically, sometimes in science class, more like a physical science class, if you would have a spring and you'd attach a weight, wouldn't the spring stretch out? And if you attached a heavier weight, wouldn't it stretch out more? So does that make sense as the length is going to go higher as the weight is heavier? Okay, so interpret the slope. The spring, you could say it that way, the spring gets 2 inches longer for every, what's the unit here? Pound. 1 lb. I don't know why the abbreviation for pounds is lbs, but it is, okay? Interpret the y-intercept. What was the y-intercept? 8. And so what that means is the length with no weight is 8.
Bless you.
Okay.